So here we are talking about module number 2. Module number 2 covered a couple of different topics. The primary one was balancing chemical reactions. From there, we were able to dive into eliminating reactants. And then one type of problem that we saw was one in which we talked about reaction cycles. I'm going to go through those over the next few slides here. The first thing that I want to get into is balancing chemical reactions. I'm eating an ice cream sandwich right now because ice cream sandwiches are fantastic. If you don't have one, I strongly recommend that you go out and get one. But more important than that is balancing a chemical reaction. What you have to do is be able to identify the parts of a chemical reaction. Left-hand side are your reactants. Right-hand side are your products. This line right here with the arrow shows the direction which our reaction is going. Okay, so on the left-hand side, we have two different reactants, CH4 and Cl2. Okay, now if we break that out a little bit, what we have is 4H and 1C, and we've also got 2Cl. Okay, on our product side, we have 1C Cl4 and 1HCl. Okay, so what that means is we've got 1C and 4Cl, and we've also got 1H and 1Cl. So what we need to do is we need to put we need to put coefficients in front of each one of our different reactants and products so that we have the same number of chlorines, carbons, hydrogens on the reactant side and the product side. Okay, now what I would recommend is always find something that kind of stands out. For instance, in this chemical reaction, we've got chlorine. Chlorine is present as Cl2, and it's present in CCl4 and HCl. Now, whenever I see that Cl, what I'm thinking is I want to change my coefficient here, and I want to change my coefficient here. And I'm going to do something that's a little bit tricky, and what I'm going to do is I'm thinking I've got a total of 4 Cl's, a fifth Cl, so that would give me an odd number of Cl's on the product side and an even number on the reactant side. So what I want to do is I want to just go ahead and put a 2 in front of that HCl. Okay, whenever I do that, what does that give me? Well, that changes my number of chlorines. It gives me a total 6. So if I wanted to balance that, I'd come up with a 3 here. So I'd have 6 Cl's, then 4 Cl's, and 2 more. So 6 total Cl's. So my Cl's would be balanced, which would be great. Okay, but what does that mean? What's the consequences of doing that? Well, when I put that 2 in front of the HCl, it gets me 2 hydrogens. How many hydrogens do I have on my reactant side? Well, I've got 4. Okay, so then let's try something else. Let's go ahead and change that from a 2 to a 4. 4 HCl. By doing that, I've balanced my hydrogens. Okay, I've increased my Cl's from a total of 5 over here to make it 8 Cl's. Okay, so I've got 8 Cl's over here. So then what could I do with my Cl2? If I put a 4 in front of that, that gets me 8 Cl. So I've got 8 Cl. So let's take stock of everything. That gets me 8 Cl's as a reactant and 8 Cl's as a product. It gives me 4 hydrogens. It gets me 4 hydrogens as a reactant. Now, number of carbons. I'm going to use green here. I've got 1 carbon in CH4, I've got nothing there, and then I've got 1 carbon in CCl4. So this actually balances my reaction. So what I did was in my first attempt, I tried to balance Cl's, but I realized whenever I balanced my Cl's, then I had to balance my H. Okay, so my process was first balance my Cl's, then balance my H's, but then whenever I do this, circle back, balance my Cl's. And whenever I did that, well, I was able to very quickly and easily balance my reaction. Okay, I hope this is helpful. We're going to use the same reaction moving forward for our next step. Okay, so anytime you look at a balanced chemical reaction, there are a couple different ways that you can look at this. You can look at this as a mole ratio. You can also look at it in terms of the individual reactants. Okay, so what this breaks down to is if you had one molecule of CH4, it would need 4 molecules of Cl2 to react. And if you had those two things, that one molecule of CH4 and 4 molecules of Cl2, you would produce one molecule of carbon tetrachloride and 4 molecules of hydrochloric acid, HCl. Okay. Now another way that you can look at this is if you had, I'm just going to change this up a little bit, if you had 1 mole of CH4, you would need 4 moles of Cl2, and you would produce 1 mole of CCl4 and 4 moles of HCl. Okay. Now let's think about this in a slightly different way. Let's say you had 4. I'm going to actually draw that elsewhere. Let's say you had 4 moles of CH4 and 4 moles of Cl2. What would you produce? You would produce 1 mole of CCl4 and 4 moles of HCl. Okay, that seems a little bit tricky and that seems a little bit challenging, but you have to think about this in terms of the individual ratio. 1 molecule of CH4 reacts with 4 molecules of Cl2. 1 mole of CH4 reacts with 4 moles of Cl2. 4 moles of Cl2. So if you had 4 moles of CH4, how many moles of Cl2 would you need? You'd need 4 times as many. You would need 16 moles. So 4 moles of CH4 needs 16 moles of Cl2. Okay, and so if we were presented with this scenario where we had 4 moles of CH4 and 4 moles of Cl2, what we would be able to categorize Cl2 as we would categorize this as the limiting reactant. What does that mean for CH4? We would classify that as the excess reagent. Okay, now anytime that you're presented with this information, think about every chemical reaction taking place in terms of a molar ratio. So if it takes place in terms of a molar ratio, what if you're presented with 32 grams of CH4 and 64 grams of Cl2? Well, those masses, you need to convert those into moles. Convert them into moles, or a number of moles, using the periodic table and therefore using the molar mass. Now when you look at something like Cl2, for instance, that has a molar mass of 70 grams per mole. CH4, well, CH4 has a molar mass of 16 grams per mole. So when we look at these two, 64 grams of Cl2, that's a greater mass than 32 grams of CH4, but this is less than 1 mole of Cl2. Okay, so if you have less than 1 mole of Cl2, well then you need a lot less than 1 mole of CH4. So 64 grams of Cl2 is less than 1 mole of Cl2. 32 grams of CH4 is 2 moles of CH4. Okay, so can we easily identify our limiting reactant here in our excess reagent? Yeah, CH4 is totally our excess reagent because 2 moles of CH4 needs 8 moles of Cl2, and we only have 64 grams, which is less than 1 mole of Cl2. Therefore, Cl2 the 64 grams of Cl2 is our limiting reactant, and CH4 is our excess reagent. Okay, next up in this realm is again, sorry, I need to balance our chemical reaction again, 4Cl2 and 4HCl. Okay, so let's think about this. In your 1140 lab, you saw something like this. Let's think about this in terms of reaction cycles. So the first time the reaction takes place, okay, actually let's go with our 0 time. Number of moles CH4, moles Cl2, and then moles L4 and moles HCl. Okay, when this reaction starts out, what do we have? Let's say that we have 32 moles of CH4, and we've got 19 moles of Cl2. When the reaction starts, or sorry, before the reaction even starts, how many moles of CCl4 do we have? We have 0. How many moles of HCl do we have? We have 0. Okay. Now, when that reaction takes place one time, so in our first reaction cycle, I'm going to do this in a different color. I'm going to do it in green. Well, what are we going to use up? We're going to use up 1 mole of CH4. So when we use 1 mole of CH4, how many moles of CH4 do we have left? We have 31. Okay. That 1 mole of CH4, how many moles of Cl2 are we going to use up? We're going to use up 4 moles of Cl2. So how many moles of Cl2 would you have left? 15 moles of Cl2. Okay. Now, after our first time going through, how many moles of CCl4 do we have? We have 1 mole CCl4. How many moles of HCl? 4. Okay. Now the second time through this reaction, well, we're using up 1, so we're down to 30 moles of CH4. We're using up 4 Cl2, so we're down to 11 moles of Cl4, or Cl2, I'm sorry. And we're up to our second mole CCl4 and our 8th mole of HCl. Okay. Now our third round, and finally our fourth round. Let's see where that gets us. We're down to 29 moles of CH4. We're down to 7 moles of Cl2. We made our 3rd mole of CCl4 and our 12th moles of HCl. In our 4th round, we have 28 moles of CH4 left. We have 3 moles of Cl2 left. We have our 4th mole of CCl4 made, and we have our 16th mole of HCl made. Okay, let's talk about our 5th. In our 5th round, well, once we get to our 5th round, can we identify what our limiting reagent and our excess reagent is? Well, if we wanted to use up 4 more moles of Cl2, do we have that? No, we don't. We have 3 moles of Cl2. So we would use all of those up, but then our reaction is going to stop. So we're going to have 0 moles of Cl2 left. Now, when we use up 3 moles of those remaining 3 moles of Cl2, we're only going to be able to use up 0.75 moles of CH4. So that means we're going to have 27.25 moles of CH4 left. Okay, so this is our excess, because after 5 rounds of our reaction, after our reaction has completely used up our other reactant, well, we still have some of that left. Our Cl2, that is limiting. And what are we going to be able to produce? We're going to be able to produce another 0.75 moles of CCl4, so we're at 4.75 moles of CCl4, and we're going to be able to make 3 more moles of HCl, so we'll make 19 moles, or our 19th moles of HCl. So This is just in a different perspective. Think about every single time that a reaction is going to take place. Every single time you'll use one reactant, how many of that other reactant are you going to use? How many of that product are you going to make? It's another perspective on how to view limiting and excess reagents. I hope this was helpful, and thanks.